This is 6-1, Properties and Attributes of Polygons. Try the warm-up problems and hit play when you're ready to see the answers. Here are the answers to the warm-up problems: triangle, quadrilateral, 24, 270, and 4. A polygon is a closed, plane figure formed by 3 or more line segments, so they're not curved, there's no curves, and there's no intersections within the figure. Each segment intersects exactly 2 other segments only at their endpoints, so that a polygon cannot intersect itself, and no 2 segments with a common endpoint are collinear, so that a polygon that appears to have n vertices actually has n vertices. So here's some vocabulary that goes along with polygons. So the first thing you have to know is that each segment that forms a polygon is a side of the polygon. So this is side AE, for instance, over on the left here. The common endpoint of 2 sides is a vertex of the polygon. So where 2 sides meet at one point, that's a vertex, like point A is a vertex. A segment that contains any 2 non-consecutive vertices is a diagonal. So as long as they're not consecutive next to each other, then it is a diagonal. So B is not next to vertex D, so that is a diagonal. And you're going to have to memorize the names of the polygons. So 3-sided triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 is dodecagon. So 11 and 13 and any of the other numbers are n-gon. So 13 gon, 11 gon, 15 gon, etc. You can name a polygon by the number of its sides, as the table shows, and here's an example. Polygon ABCD is a pentagon because it has those 5 vertices, so it's a pentagon. Okay, we're going to see if each figure is a polygon. So A is a polygon, B has all straight edges, straight lines, it's closed, so that is a polygon, and C has a curved edge, so it is not a polygon. And then jump down to the now you try. A is a polygon, B is not because of this intersection right here in the middle of it. And C is closed, has no curved edges, so C is a yes. So I'll write those in for you. So yes, yes, no, yes, no, and yes. And then it wants us to name it by the number of sides. So going back, we've got 1, 2, 3, 4, 5, 6. Hexagon, 1, 2, 3, 4, 5, 6, 7. Heptagon, 1, 2, 3, 4, 5. Pentagon. And the last one, we've got 1, 2, 3, 4, 5, 6, 7, 8. Octagon. In order for a polygon to be a regular polygon, it has to be both equilateral and equiangular, so all the side lengths are congruent and the angles are congruent. If a polygon is not regular, we call it irregular. A polygon is concave if any part of the diagonal contains points in the exterior of the polygon. So think about this. If there are 2 non-consecutive points that form a diagonal outside, then it is concave. I just like to think of the fact that the shape is caving in. I can see it's kind of caving in right here, so it's concave. Convex does not have that happening. So I know that example 2 is, tell whether each polygon is regular or irregular. So I see that the angles aren't all the same, so I know it's irregular. And then I also need to say if it's concave or convex. Well, it's not caving in anywhere, so it's convex. I see that this is caving in right here, or there's a diagonal outside if you want to think about it that way. So this is concave. And anything that's concave is automatically irregular. And number C, it's convex, it's not caving in anywhere, and we've got all angles and all sides are congruent, so therefore it is regular. Okay, for the now you try, I see that I don't have all sides congruent on this one, so it's irregular, and it's not caving in, so it's convex. We're not caving anywhere on this next one, so it's convex. And every angle is the same, and every side is the same, so it's regular. And this is concave, which makes it automatically irregular. Makes sense, because we've got some angles here that would not be the same as the other marked angles. I'm going to ignore this and jump right down to the theorem. The polygon angle sum theorem. The sum of the interior angle measures of a convex polygon can be found using this formula. So for instance, if I have a triangle which has 3 sides, I can use this n minus 2 times 180 to see how many degrees are in the triangle. Well, we take the n, the number of sides, and we place that there, so we get 3 minus 2, which is 1, times 180. So in a triangle, there's 180 degrees. In some sort of quadrilateral, it's 4-sided, so I would do 4 minus 2 times 180, which would be 2 times 180. A quadrilateral contains 360 degrees. You could do a pentagon, a 5-sided. You take the formula, 5 minus 2 times 180. You get 3 times 180, which is 540 degrees. So all this tells me how many degrees are inside a polygon. Okay, for example 3, find the sum of the interior angle measures of a convex heptagon. So I know that that's 7 sides. So interior angles, it's going to be n minus 2 times 180. So that's going to be 7 minus 2 times 180. 5 times 180. It's 900 degrees. Okay, find the measure of each interior angle. That's going to be a little bit different from what we've been doing. So of a regular 16gon. So we start with the total, 16 minus 2 times 180. Which is 2,520. But if I want to know how much is in each angle, then I'm going to have to divide that by 16. So when I want to know each angle, what you're going to do is n minus 2 times 180 divide by the number of sides, n. Okay, find the measure of each interior angle of this pentagon in particular. This is another scenario. So what this means is that this pentagon is 5 minus 2 times 180, which is 3 times 180, so that's 540 degrees. But I already know these angles are 32C, 32C, 18C, 35C, 18C. I can add all of these up and set them equal to the 540. Oops. Plus 18C equals 5. So C equals 4. So now I can find each interior angle. So measure of angle A is going to be 35 times 4, which is 70, times 2 is 140. The measure of angle B and the measure of angle E are the same. That's 18 times 4, so that's going to be 72 degrees each. And the measure of angle C and D, 64 times 2 is 128 each. And I can double check and just add those and make sure that they add up to 540. Okay, now you try. So the first one is find the sum of the interior angle measures of convex octagons. So sum of interiors n minus 2 times 180, which is 6 times 180, 1080. Find the measure of each interior angle of a regular nonagon. So each interior angle of the regular nonagon. So 9 minus 2 times 180 divided by 9. So 7 times 180 divided by 9. That's going to be 140 degrees for each angle. Now this one they gave us my measurement, so I'm going to add these up. I've got 1C plus 1C plus 3 plus 3, so that's 8C is equal to, I need to know how many degrees in the quadrilateral. So if you don't already know that it's 360 degrees, you would do 4 minus 2 times 180. So divide both sides by 4, and C is equal to 360 divided by 8, which is 45 degrees. So I know that measure of angle P is 45 degrees, and so is the measure of angle R. And the measure of angle Q is 135 degrees, and so is the measure of angle S. And double check, those should add up to 360 degrees. Okay, for the polygon exterior angle sum theorem, you need to know that all exterior angles, no matter which polygon it is, adds up to 360. So find the measure of each exterior angle of a regular 20gon. That's going to be 360 divided by n. So 360 divided by 20. So each one is 18 degrees. Now here we know that all of these add up to 360 degrees. So I'm going to add my 16 plus 10 plus 28 plus 15 plus 18 plus 33 is equal to 120b is equal to 360 degrees. So divide by 120, and b is equal to 3. And that's what it asked me to do, find the value of b. So I'm done. Okay, for the now you try, find the measure of each exterior angle of a regular hexagon. That's going to be 360 divided by n, which is 360 divided by 6, which is 60 degrees. Find the value of a in the polygon. So all of these add up to 360 since they're all exterior. So 7a plus 2a plus 2a plus 3a plus 6a is equal to 360 degrees. So 7, 9, 11, 14, 20 is equal to 360 degrees, 20a, sorry, divided by 20, and so a is 18. Since this is a regular decagon, you just take 360 and divide by 10, and so the measure of angle CBD, that exterior angle, is going to be 36 degrees. So I just did 360 divided by n since it was exterior.